Lots of math problems on the SAT have answer choices that actually aren't numbers. They could be percentages, they could be ratios, or in the case of a problem like this, they can have variables in them. It can be very difficult for you as a student to know how to even start problems like this, because really, where do you go? How do you start doing math? The good news is we have a method to deal with problems just like this. It's called substitution or picking numbers. So let's look at this problem. It says if a to the b plus a to the b plus a to the b plus a to the b equals a, then which of the following answer choices expresses a in terms of b? Expresses a in terms of b. That's confusing language right from the get-go. But to understand how these variables are related, let's just pick some numbers and do some arithmetic. So I see in my answer choices a whole bunch of b's. Let's start with that. Let's say b equals, I don't know, pick a number, 7. How about 7? So the idea here is to take our b equals 7 and calculate what a is, because that's math that you can do. You might be saying to yourself, 8 to the 7th is a very inconvenient number, and you would be right. So let's make our life easier. Let's not choose 7. Let's choose 2. And with b equals 2, we can now calculate 8. So I have 8 squared plus 8 squared plus 8 squared plus 8 squared equals a. And you've all got calculators on this test, so you can very quickly enter that into your calculator. Or if you're a quick study, you'll know that 8 squared is 64, times 4 gets me 256, and let's put a box around that because it's very important. So now back to the question at hand. What do they want from us? They want from us which of the following answer choices expresses a in terms of b. Well, now we know that a is 256 when b is 2. Well, look what we've done. We've now created ourselves a rule that we can use to test these answer choices. So let's take our b of 2 and pop it into those answer choices looking for the guy that tells me 256. If I do that here, I'll get 2 to the 12, which happens to be a large number, 4,096. That's not right. A lot of students think it's 32 to the b. Let's try that. 32 squared, that happens to be 1,024. 8 to the 4b, well, that's just ridiculous. That's 8 to the 8th power. That is a very large number that I don't want to calculate. And if we go back to b, we'll find that that guy is 2 to the 8th, which is exactly 256, which makes b the right answer to the question. And we can do this in a much more concrete way using arithmetic. A lot of you might be saying that this totally would not work in school, right? How would your math teacher feel about this? Probably not very good. So let's just take a moment and think about how your math teacher might approach this same problem. So your math teacher is going to rely on a whole lot of exponent rules. You learned these in Algebra 2 or pre-calc. Things like x to the a times x to the b. That guy's x to the a plus b. Or something like x to the a to the b power equals x to the a times b. You might be saying to yourself, though, exponent rules for addition. Yeah, there aren't any. That's exactly why this is a clever SAT problem. So you have to be clever right back. How many 8 to the b's are there? There are 4. So we can say a equals 8 to the b times 4. Ah, okay. Now I have multiplication, so I can use my exponent rule, or at least I could if I had a common base. So let's make it that way. The common base here would be 2. 8 is 2 cubed, while 4 is 2 squared. Now I've got a problem I can use my exponent rules on. 2 to the 3 to the b is 2 to the 3b times 2 to the 2 gets me my unlikely looking but totally true answer, 2 to the 3b plus 2, which is, of course, what we found initially. But I want you to ask yourself, what do you think is easier? Being ridiculously clever followed by being fiendishly clever followed by correctly remembering and applying 2 different exponent rules? Or b equals 2?